Look at this, there's this cool ocean thingy, man. I think I gotta use this. Yeah, this looks juicy. So yeah, cloned it and then started it with Godot, which only takes a second, as we all know. And then there was it. This amazing ocean. So yeah, put in a rigid body, give it some collision, and of course some visuals, a little gray box, make it brownish to look a little like a boat, and then start the thing. So it turns out that it doesn't interact with rigid bodies, and the displacement of a vertex is not only in the y-axis, but in all three axes. And the data to trace back the transform of each vertex is not even accessible from the CPU. So I banged my head against this beautiful code written by Ethan Trong, and I read a little in the Godot documentary. Finally I got it, and here it is. You can use the getHeight function that I added to the water.gd script. It receives a global position and returns the global height on the surface of the water. So here's the result. It looks a bit jittery, but the buoy thingy is floating on the water. Since water is transparent and translucent, I added an edge fading effect, just like the distance fade effect. Also, any object submerged in the water changes its colors according to some absorption spectrum. You can adjust the maximum visibility range of the red, green and blue color components that result in these realistic looking underwater transitions, or you do silly stuff with it. Then I did a very rudimentary performance test with 200 probes, measuring the water height in different positions. The frame rate is about 100 FPS for this scene, which is about the same as having only one probe, so that's very good. The performance impact is not really produced by the probes. The costly operation is to bring the texture data from the GPU to the CPU. I'm still working on a way to decouple an extra thread to do this in parallel to the main thread. This would avoid the stalling. However, it will introduce a small delay of 2 or 3 frames, but that is the best we can have. So the frame rate increases to about 130 when I stop the GPU to CPU data transfer. So what you see here is my best effort to have some kind of a simulation of a ship. It's a rigid body that receives forces from below, with some water splashing added and a mask in the body to avoid waves clipping through the body from below. And the buoyancy system, I think, has to be improved. The bouncing is a bit wild. And also the integration with some kind of sail forces and so on. But more updates on that later. So here's the repository on GitHub. It's a fork from the 2retro repository, Godot Ocean Waves. And down here I have a description of the features that I implemented and I want to implement, with some references and explanations and thoughts that I have. And if you want to contribute, please do so. You can fork it yourself and create a feature branch and then make pull requests. So maybe we can together make this a really cool thing that everybody can use and create awesome ocean games.